All right, so today we're going to look at 3.6 chain rule. All right, so basically this is going to give us, I don't know if you ever even thought about it, but when we did the trig functions and we did sine x, and then we were looking at the derivative of sine x is equal to cosine x. So what's this going to allow to happen is that we're going to be able to do the derivative of something more than just x, sine x. We can do sine x squared, you know, sine x squared plus 2 and so on. We'll be able to do the derivative of other things other than just x. And so we'll look at how to do that in this section. All right, so the chain rule is dy dx. All right, so it's dy dx, wherein we're going to take, we're going to let one part of it, the inside part, be equal to u, and then we're going to take the derivative of y with respect to u, and then take the derivative of u with respect to x. So what do we mean by that? So let's say if we have y equal to 3x squared plus 1 raised to the second power. And so what ends up happening, and the more you do this, the more you get used to taking derivatives, the less you'll lean on actually writing all the stuff out, and you'll just see how that you have to take the derivative of an inside function and the derivative of the outside function. And what I mean by that is that we have an inside function right here that we have to give an account for, 3x squared plus 1, but we also have an outside application, which is the square that we have to give an account for when we take the derivative. And so that's pretty much how I process it, is that I have to take the derivative of the outside and the derivative of the inside. All right. So if we let 3x squared plus 1 be u, that means y is equal to u squared. So now notice there are two parts here. We want to take the derivative of y with respect to u, and then the derivative of u with respect to x. So if I take this is y. So if I do dy du, that's going to be, well, I will bring the 2 down, subtract 1 from your exponent, so that's just 2u. And if I take the derivative of u with respect to x, bring down the 2, subtract 1 from your exponent, and don't forget the derivative of any constant. Derivative of any constant is 0. So that's just, oh, I put u, should be x. All right. Questions so far? So we had an inside part and an outside part. You let the inside part be equal to u. So that was 3x squared plus 1. And so if that is equal to u, y is equal to u squared, because you substitute in u for the 3x squared plus 1. Then, like I said, according to your chain rule, dy over du, that's taking the derivative of y with respect to u, which is what we did here, Then we take the derivative of u with respect to x, which is what we did here. So we have these two pieces. So now we can go ahead and take those two pieces and multiply them together. dy du is 2u times 6x. But also don't forget that we didn't start off with u. We had to plug u back in. All right, so we can simplify this. 6 x times 2 is just 12x sitting on the outside. And then we can go ahead and distribute into the parentheses 36x cubed plus 12x. All right, so differentiate sine x squared plus x with respect to x. All right, so like I said, what we have here, just like before, we have an inside function, which is x squared plus x. Then we have an outside function, which is sine. So if you want to go through this process, then what you would do is let u be equal to x squared plus x. And then, of course, your y is that sine. Or you can look at it like I was saying before, is that you take the derivative of the outside, which is your sine function. So this is my outside function. This is my inside function. So take the derivative of the outside, derivative of sine is cosine. I'm gonna bring it down. So that's cosine of x squared plus x times, now the derivative of the inside, take the derivative of both of these individually. So that'll be 2x plus 1. So don't forget your power rule. You bring your 2 down in front of the x, subtract 1 from your exponent. So that's how we have 2x to the first power. And then your x, you bring 1 down front because all you have is 1 is your exponent. And then subtract 1 from that. That gives you 0, which cancels out your variable altogether. So that's why you have 2x plus 1. And there's nothing really more you could do to this to simplify it. So.
Can you scroll up? I'm sorry.
You're not. No. How far?
From the beginning.
You know what? Okay, so no, it's all right. So I was just saying that here, remember last class, we were talking about trig functions. So I'm just saying that the chain rule gives us the opportunity or the ability to take the derivative of sine of something other than just cosine. So it gives us the ability to take the sine, the derivative of sine of x squared. So that's why all of the trig functions that we talked about before only was being applied to x, because we didn't have the chain rule at our disposal. So now that we have the chain rule at our disposal, we can do things like this and like we just did. So I hadn't really done anything until I got right here.
Okay.
And this
Yeah.
is the chain rule. All right.
No, we don't.
Can you scroll down a little bit?
Like that.
Yes.
Mm-mm.
Is there anything else before?
Nope. It's just a chain rule, and then that was our first one right there.
Okay.
And that's the end of the first example. Then we came down here for the second example. All right, let's see.
Can you scroll up one more time? I'm sorry. Yeah,
Mhm.
right there. Okay, I got it all. Thank you.
Okay, no problem. All right, so let's do this one. Okay, so we want to take the derivative of 5x cubed minus x to the fourth raised to the seventh power. Once again, we have an inside part and an outside part that we want to give an account for, that we want to take the derivative of. So we take derivative of the outside. Get it again. You're going to bring your 7 down front. What's on the inside stays the same. And then subtract 1 from your exponent, so you have 6 right there. All right, so now we're going to take the derivative of what's on the inside. So this is what I'm going to do. I'm going to rewrite that down here. All right, so now the derivative of what's on the inside. Got 5x to the third power, so we bring down 3. Subtract 1 from your exponent, that's 2. Then you bring down 4. Subtract 1 from your exponent, that's 3. All right, so now we have 7, 5x cubed minus x to the fourth raised to the sixth power. Then 15x squared minus 4x cubed. And that's about it. So the only thing you could do is take the 7 and multiply it into that parentheses right there. But let me see, look at the example. They left it like that, so that was good enough. So once again, you're taking derivative of the inside quantity or the inside function and then the outside, or vice versa. As long as you're doing both of them, you multiply them together. All right, so we have here derivative of 1 over 3x minus 2. So probably be best if we rewrite this as 3x minus 2 to the negative first power. So don't forget, if you have anything in your denominator, if you want to raise it up to the numerator, you can rewrite it with the negative exponent. All right, so we have inside, outside. So as far as the outside go, we're gonna bring the negative 1 down front. Be careful here, if you subtract 1 from negative 1, that's going to be negative 2, because negative 1 minus 1, that'd be negative 2 as an exponent. Then take the derivative of what's on the inside. We have 3x. When you take the derivative of 3x, that'll just be 3. Derivative of any constant would be 0, so you're just left with 3. You can drop that 3x minus 2. Now we want to write it as simple as possible. So we drop the 3x minus 2 to the negative second power, back down bottom to your denominator, to write it with a positive exponent. And we'll have 3 on top. So that would be your exponent. All right, so for the next one, this can be rewritten as sine x to the 5th power. Those mean the same thing. So we have inside function, outside function. And so we're looking at sine x. Well, I'll do the outside first, bring the 5 down front. Subtract 1 from the exponent. That'll give me 4. All right, now the inside derivative of sine is cosine. So the most simplified way of representing this is sine 5 sine to the 4th power, or sine to the 4th power of x, sine of x to the 4th power times cosine. That sounds better. Any questions? Any questions? All right, how about All right. I want to take derivative of tan of 5 minus sine of 2t, and we're doing it with respect to t. T is our variable. So we have our inside and we have our outside applications or functions. All right, so the inside, let's do the outside first. I always say inside, but I mean to do the outside first. We have tan, so we want to turn that tan into secant squared. When you take the derivative of tangent is secant, so you do secant squared of 5 minus sine 2t. And that's going to be times the derivative of the inside function. So we have 5 minus sine 2t. So derivative of 5, remember the derivative of any constant is going to be 0. And we're looking at now the derivative of negative sine 2t. So we got to be careful here. So the derivative of negative sine, now it'd be different if it was just the derivative of negative sine t, but it's the derivative of negative sine 2t. So that means we're going to have to do the chain rule again for this part. We have this inside part, which is 2t, and of course we have the outside part, which is sine. So that's negative cosine. The derivative of sine is cosine, but we already had a negative sitting out front, so that's what that negative is. So there's negative cosine 2t times the derivative of the 2t, which is 2. All right. Any questions so far before we finish it off? All right, so let's put it all together. Sine secant, I mean not sine secant, secant squared of 5 minus sine 2t times negative 2 cosine 2t. All I did was take that 2 and put it out front. And you can either leave it like that or put that cosine out front. Either way, it'll be fine. Yep. So that's it. Questions? Any questions? Guess we do at least one more to make sure we're good. All right, so another one of the examples gave us this. We want to take the derivative and find the derivative of 1 over 1 minus 2x to the third power. Once again, if we have one like this, raise it to the numerator. 1 minus 2x to the negative third power. Once again, inside function, outside function. So bring the negative 3 down front. 1 minus 2x. Subtract 1 from that negative 3. Once again, be careful with your negative exponents. When you subtract 1 from it, you're actually, adding to the negative. So it's going to be negative 4. Negative 3 minus 1 is negative 4. Times the derivative of the inside. Derivative of a constant is 0. And that's going to be negative 2. And the x disappears. Drop the quantity with the negative exponent back down bottom to make it positive. And I can multiply the negative 2 and negative 3. And I have positive 6 on top, 1 minus 2x to the fourth power down bottom. All right. Any questions? Questions?
No, it makes sense.
Okay, sounds good. All right. So I know we got time left in class, but I'm still trying to play this thing by ear. Play it close to the vest as much as possible, dealing with, people not necessarily having the Wi-Fi and everything like that, and with people being behind. So I won't do anything new today. For those of you who are able, make sure you take advantage of it. Of the fact that we're not doing but so much per class. And make sure you stay on top of the sections. Homework posted. I think it's posted up to 3.4. I think I need to post 3.5 and 3.6. So I'll try to do that today. But outside of that, questions, concerns, comments on anything. Don't forget, that chapter 2 test is still out there. So make sure you go ahead and knock that out. And yeah, any questions, concerns, or comments?
Yeah, I got a question about the test because I have not taken it yet. Is
Yeah.
it timed at all, or do we have,
Nope. You have free reign to go in there and knock it out at your leisure, and take as much time as you like. If and this is something that you can do. Let's say if you get in there, realize you're tired, you're fried, or you're not ready, or all of a sudden you have to leave the house. Instead of leaving the test up, what you can do is treat it as if an interruption occurred. In other words, you can just hit the X button, don't log off. Of course, you don't want to hit submit, but you hit the X button up here just to close it out. And that will treat it as if a blackout or something happened, and then it'll let you pick up where you left off. So now that's not an issue with homework. Of course, with homework, you can just save and go in and out with no problem. But for your test, it won't let you go in and out like that. So you can do that for your test if you just want to, take a break or something like that. So.
All right, and all you require of us is to send you a picture of our work while we do the test. That's all you want.
Uh-huh. Yep. All right. And so, of course, that's with the hopes that you guys aren't going to cheat on it and everything like that. Just remember that you got to learn this stuff at some point because, according to your degrees, you may need it in the next class or something like that. So make sure you get this stuff. And yeah, and we'll go from there. And, we should be looking to have like a final or something where, you be doing it in front of you and all that good stuff. So you want to make sure you learn the stuff. And I'll make sure you're trying to retain it. But other than that, if you guys are good, I'm good. So I will see you on next class. I'll post this video, create it, send it to you like I did the last few. And next class, we'll get into 3.6. All right. So you guys have a good one. You take care.
All right. See y'all Wednesday.
All right.